Hello everyone, welcome to our channel 361 Physics, and here we are trying to solve some MCQ related with waves in pipes and string, and this is the second part of the video, and this part is based on the discussion of different MCQ and their solution. So let us begin with first question, and in the question 1 we can see here it is given at open end of an organ pipe. Okay, so for organ pipe, so uh, according to question we just have to analyze which of these um, options are correct. So once again let us read the question at open end of an organ pipe. So as we know, there are two types of organ pipes. One is open organ pipe having both ends as open, yeah, and another pipe is closed organ pipe, so it has its one end as closed. Okay, so this is closed organ pipe. So this question refers to the open end. Okay, so open end, uh, for open organ pipe there are two open ends, as you know that, and for closed organ pipe there are a single open end. So just we have to analyze what is formed at the open end. So as the air molecule are free to vibrate in this particular open end, that's why we can say that at the open end of either closed or open organ pipe, only antinodes are formed. So here is if we just want to find out the result, we have to see in which option this is given. That means antinode is formed. Okay, so let us read. An antinode is always produced. Okay, so rest of the thing are uh, incorrect, because if you just study this option B, a node is always produced, which is not possible. Either node and antinode may be produced, this is also not possible, and neither node, so this is rule out. That's why we can say that option A is correct. Okay, so फेरि एकचोटि बुझौँ। ओपन इन्डमा कुनै पनि अर्गन पाइपको के फर्मेसन हुन्छ भनेको छ। सो ओपन इन्डमा एयर मोलिकुलहरू फ्रिली भाइब्रेट हुन्छ होइन। वेभ फ्रन्ट प्राय हेर्ने हो भने वेभ फ्रन्ट हुन्छ यस्तो टाइपको जहिले पनि। यसको पनि ओपन पाइपको पनि ओपन इन्डमा हामीले एन्टाइनोड नै बनाउँछौँ। त्यसैले अप्सन ए करेक्ट अप्सन देखिन्छ, बिकज यो अप्सनले के भन्दैछ, एन एन्टाइनोड इज अलवेज प्रड्युस्ड। Okay, so I think this is clear. Now we are here in question number 2. The equation of stationary wave is given by. So मैले प्रिभियस डिस्कसनमा पनि भनेको छु, स्टेसनरी वेभ आउन साथ त्यहाँनिर के हुनुपर्छ भने साइन एन्ड कसको प्रोडक्ट, रिप्रेजेन्टेसन समहाउ यस्तो हुनुपर्छ, साइन एन्ड कसको प्रोडक्ट। अब साइनसँग के हुन्छ, कससँग के हुन्छ त्यो इम्पोर्टेन्ट होइन, तर साइन एन्ड कसको प्रोडक्ट हुनुपर्छ। ओके, सो साइन एन्ड कसको प्रोडक्ट भएको अप्सन हामी सेलेक्सन गर्छौँ, एन्ड अप्सन ए मोस्ट फिजिबल अप्सन देखिन्छ, बिकज साइन kx टाइम्स कस ओमेगा टी, एज वेल एज यु क्यान सी हियर द एम्प्लिट्युड इज ट्वाइस अफ इन्डिभिजुअल एम्प्लिट्युड, भनेको एम्प्लिट्युड पनि मोडिफाई भएको छ, त्यसैले यो अप्सन करेक्ट अप्सन देखिन्छ। Okay, so to find out the stationary wave, equation of stationary wave, we have to analyze which of them uh, contains the product of sine and cos, as well as the modified, okay, this is modified expression for amplitude. So option A contain all of these criteria. Okay, that's why option A is correct option. Now we are heading here to the question number 3. The length of a closed organ pipe is L. If the velocity of sound is V, then the frequency of its fundamental note is. So this is quite easy, uh, because clearly given here the nature of pipe is closed organ pipe. That's why we can say that for fundamental mode the frequency is 4 b by 4l. Okay, so option 3 is your correct option. बुझ्यो होला आई थिंक, किनभने क्लोज अर्गन पाइपलाई फन्डामेन्टल मोड हुन्छ भी बाई 4l, त्यस पछाडि सेकेन्ड मोडको लागि हुन्छ 3 भी बाई 4l या, एन्ड थर्ड मोडको लागि हुन्छ 5 भी बाई 4l हैन। सो हामीलाई यो सोधेको त छैन, मैले जस्ट रिकल गरिदिएको। त्यसैले अब हाम्रो फन्डामेन्टलको लागि एक्सप्रेसन भी बाई 2l देखिन्छ, त्यसैले अप्सन सी करेक्ट अप्सन देखिन्छ। Question number 4. A sonometer wire is vibrating in its second overtone. Okay. So second overtone भन्ने वर्ड आउन साथ हामीले बुझ्नुपर्छ this is third mode of vibration. Okay. We may say that there are two nodes and two antinodes, one node and two antinodes, four nodes and three antinodes, three node and four antinodes. Okay, so first of all, we have to know the meaning of this third mode. So as we know that for string or wire, the number of mode also refers to the number of loops. Okay, which means in second overtone or third mode of vibration there are three loops. So let us draw three loops. This is first loop, this is second loop, and this is third loop. So just count these node, and node. There are four nodes and antinodes, 1, 2, and 3 antinodes. So we have to analyze the correct option, which must contain there are four nodes and three antinodes. So option A, two nodes and two antinodes, this is not correct. One node and two antinodes, this is also incorrect. Four nodes and three antinodes, so this is correct option. Okay, now we are here in question number 5. The end correction of the vibration of air column in a tube of circular cross section will be more if the tube is increased in length, decrease in length, made thinner, made wider. So just we have to recall the formulation of incorrection in terms of diameter or radius, which is equal to E equal to 0.6 r, and it can be written as 0.3 times diameter. So we can easily say that end correction is related with the diameter. Okay, diameter or radius. That means if the diameter of tube increased, then end correction also get increased. Okay, so diameter refers here to the wideness of the tube. So if we want to increase the incorrection, okay, we have to make the tube more wider. So option D is correct option. Okay, so यसमा फेरि भनिदिउँ, एन्ड करेक्सन हैन कुनै ट्युबमा कति बेला बढी हुन्छ भने सोधेको छ। एन्ड करेक्सन हाम्रो थाहा छ केसँग रिलेटेड हुन्छ भने रेडियस अर डायमिटरसँग रिलेटेड हुन्छ। रेडियस र डायमिटरले रिफर गर्छ वाइडनेस अफ द ट्युब। यसको मिनिङ के हो भने जति वाइडर ट्युब भयो त्यति बढी इनकरेक्सन हुन्छ। त्यसैले अप्सन डी करेक्ट अप्सन देखिन्छ। ओके, सो this is all about the question number 5. Now we are here in question number 6. A particular setup gives the following frequencies: 150 Hz, 450 Hz, 750 Hz, and so on. The setup is a tube open at the both ends, a tube open at one end and closed at the other, a wire stretched between two fixed ends, and a tuning fork. So we have to here analyze the value of frequencies. So if we suppose this to be 152 with the fundamental frequency, so this is 3 times of this fundamental frequency, and this is 5 times of fundamental frequency. So we are here in a conclusion that the um, fundamental frequency and the higher tones are uh, odd integral multiple of this 150, or we can say that there are odd harmonics, only odd harmonics. Okay, that's why we are here uh, clear about that. um, this is um, a closed organ pipe. Okay, so option uh, option A is related with open organ pipe because it is said that a tube open at the both end. So this is incorrect. A tube open at one end and the close at the other end. So option B is correct option. Okay, so फेरि भनौँ के भनेको छ भने कुनै एउटा सेटअप छ हामीलाई थाहा छैन र त्यो सेटअपले 150 हर्ट्ज 450 हर्ट्ज एन्ड 750 एन्ड सो अन फ्रिक्वेन्सी दिन्छ भने यो सेटअप के होला भनेर सोधेको छ। मैले के भने भन्दाखेरि 150 फन्डामेन्टल एजम्सन गर्ने भने दिस इज 3 टाइम्स अफ फन्डामेन्टल एन्ड दिस इज 5 टाइम्स अफ फन्डामेन्टल फ्रिक्वेन्सी। सो odd number of harmonics are present, यहाँबाट कन्क्लुड गर्न सकिन्छ। यसको मिनिङ के हो भने odd number of harmonics भनेको क्लोज अर्गन पाइपमा हुन्छ। अब फर्स्ट अप्सन भनेको अ ट्युब ओपन एट बोथ इन्ड भनेको ओपन अर्गन पाइपको कुरा गर्यो त्यो हुँदैन। अ ट्युब ओपन एट वान इन्ड एन्ड क्लोज एट द अदर इन्ड भनेको क्लोज अर्गन पाइपको कुरा गरिरहेछ, त्यसले हामीलाई थाहा छ। इन द क्लोज अर्गन पाइप देयर आर ओन्ली odd number of harmonics, त्यसैले हाम्रो अप्सन बी करेक्ट अप्सन देखिन्छ। Okay, so this is question number 7. The frequency of vibrating wire in an is an sorry. When area of cross section of wire is half and tension is double, the frequency becomes. So this is related with calculation. We have the expression for the fundamental mode of vibration for a wire is F equal to 1 by 2L root over T by mu. This is mass per unit length. So in first line it is given that the fundamental frequency is uh, n. Okay, in first case. So here I am going to replace this f by n. Okay, this is n. And in the second part the question said that when area of cross section of the wire is halved and the tension is double. So in next case, suppose n dash is the frequency in second condition, then tension is double, that means twice of twice of t, and we have to modify this part mass per unit length, and we have to make the expression in terms of area of cross section. So as we know that mass per unit length is m by l, and mass can be written as the volume product of volume density, okay, by L, and this further can be written as A times L times rho by L. So these two cancel out. So in the place of mu we can write A times rho. So here uh, in the place of mu I'm going to write uh, first of all let me draw this. Okay, so I'm going to draw this mu, and here I can write A times rho. Okay, and in the second case I'm going to replace this A by 2, and rho remains same because the material of wire is same. So these two will multiply here, 2 into 2, that means 4, it becomes 4. Okay, so if you take this 4 outside of this root, then okay, let me drop this portion. Okay, so okay, so tension cross section of wire is half, so I have written as A by 2, and tension is double. That's why this is 2 times of T. So here I am going to write it as 1 by 2L, and this will be 4T by A rho. Okay, if I take here 2 as common, and I'm going to write this remaining expression as 1 by 2L, okay, and root over T by A rho, and this is the expression of n. So n dash equal to twice of n. So option B is correct option. Okay, now here we are in question number 8. Okay, so if the frequency of vibration of string is increased by a factor 2, then the tension in it will be. Okay, so as we know that the frequency is directly proportional with T, and frequency is made here double. Frequency is made here double. So what about the tension? So tension must be increased, but by what factor? So here we have to just put here square, and it will be 2 square, so T equal to 4. Okay, it means that we have to increase the tension by 4 times. यो सर्टकट वेमा गर्न सकिन्छ MCQ लाई यसरी नै सल्भ गर्ने फ्रिक्वेन्सी डाइरेक्टली प्रोपोर्सनल विथ रुट ओभर टेन्सन र टेन्सन फ्रिक्वेन्सी 2 टाइम्स इनिशियली छ मैले जस्ट 2 लेखेँ यहाँ है MCQ गर्ने मेथड नै यस्तै हो डिटेल हामी जाँदैन अनि डाइरेक्टली प्रोपोर्सनल छ हुन त लजिकली यो डाइरेक्टली प्रोपोर्सनल स्क्वायरिङ बोथ साइड यस्तो लेख्न मिल्दैन हैन तर MCQ लाई यो सबै चल्छ सो 2 स्क्वायर एन्ड यो स्क्वायर गरिसकेपछि 2 टु द 4 हुन्छ सो हामी लगभग एउटा कन्क्लुजनमा छौँ कि टेन्सन फ्रिक्वेन्सी ट्वाइस ले इन्क्रिज गर्नको लागि टेन्सन 4 टाइम्स ले इन्क्रिज गर्नुपर्छ कन्डिसन रिमेनिङ प्यारामिटर्स आर कन्स्ट्यान्ट okay so this is question number 9 the fundamental frequency in a closed pipe is 200 hertz then its second overtone so हामीलाई थाहा छ in general पहिला त सेकेन्ड ओभरटोनको मिनिङ जान्नु पर्यो सेकेन्ड ओभरटोन सेकेन्ड ओभरटोन always refers the third mode of vibration किनभने मोड भन्दा एक लेस हुन्छ ओभरटोन ओके सो थर्ड मोड अफ भाइब्रेसन भनिसकेपछि क्लोज अर्गन पाइपलाई हामीलाई थाहा हुन्छ अड नम्बर हुन्छ थर्ड मोड भनेपछि 5 टाइम्स V by 4L सम्म यस्तो एक्सप्रेसन हुन्छ that means 5 times F1 clear so this will be equal to 5 into 200 which is equal to 1000 hertz हैन so option D correct option देखिन्छ सम्झिने है जहिले पनि ओभरटोन जहिले पनि मोड भन्दा 1 लेस हुन्छ इफ मोड सपोज मोड n हो भने ओभरटोन हुन्छ ओभरटोन क्यान बी रिटन एज n minus 1 सम्झिनु पर्छ है यो एकदम हेल्पफुल हुन्छ क्वेशन नम्बर 10 An open organ pipe vibrates in its fundamental mode. The pressure variation is maximum at. As we know that maximum pressure always occurs at the node or nodal point. So as the question said that open organ pipe and it vibrates in its fundamental mode, that's why from the wave front we know that node is formed in between two antinodes and its location is exactly half of the tube. Okay, this is if this is the length of the tube, so up to here the length will be 1/2 of the tube. So the option is C is seems to be correct because this option said that the middle point of the pipe. So at the middle point of the pipe we can get the node. So node in the nodal zone or nodal point there is maximum pressure. Okay, so फेरि सुन्ने An open organ pipe vibrates in its fundamental mode. The pressure variation is maximum at भन्दैछ हामीलाई के थाहा छ भने नोडमा म्याक्सिमम प्रेसर हुन्छ ओपन organ pipe भनेको छ अनि अर्को भनेको चाहिँ फन्डामेन्टल मोड है ओपन organ pipe फन्डामेन्टल मोड सो वेभ फन्ट हामीले ड्र गर्यो रफली र यो वेभ फन्टको बेसिसमा हामी के कन्क्लुड गर्छौँ भने नोड इज फर्मड एट द मिड पोइन्ट अफ ट्युब त्यसैले हाम्रो अप्सन पनि मिडल पोइन्ट भएको अप्सन करेक्ट अप्सन हुन्छ okay now here we are in question number 11. The velocity of sound in air is 320 meter per second. A pipe closed at 1 end, that means this refers to the closed organ pipe, has a length of this much 1 meter. Neglecting the end correction, the air column in the pipe can resonate for the frequency. So अब यहाँ अप्सन्सहरू छ 80 हर्ट्ज to 240 320 80 240 and then 400 के बुझ्नुपर्छ भने नि first of all, we have to find out the value of fundamental frequency for closed organ pipe. 320, this is 320, and this is 4 into 1 because length is 1. Okay, this is 80 hertz. This is the value of fundamental frequency. Now we have to check the remaining option whether they are correct or not. So what about the frequency of second mode of vibration? So as we know that the harmonics of closed pipe is always odd integral multiple of fundamental frequency. That's why it will be thrice of f1. So this is 3 times of 80, which is equal to 240 hertz. And let us take another option for third mode of vibration. This is 5 times of f1. So 5 times of 80, which is equal to 400 hertz, which means that the tube can resonate for all of these frequencies. That's why option D is here correct option. फेरि बुझ्ने velocity of sound in air 320 दिएको छ क्लोज पाइप क्लियरली भनेको छ जसको लेन्थ 1 मिटर छ र सोधिरहेछ कि यो फ्रिक्वेन्सीजहरू मध्ये आइदर 80 हर्ट्ज 240 320 और अल यो सबै फ्रिक्वेन्सीमा यो रेजोनेट हुन्छ र यसले प्रोड्युस गर्न सक्छ कि सक्दैन भन्दैछ त हामीले फर्स्टमा फन्डामेन्टल फ्रिक्वेन्सी चेक गर्छौं 80 हर्ट्ज अनि त्यहाँबाट 80 मात्रै आउँछ कि अर्को पनि चेक गर्नु पर्यो क्लोज अर्गन पाइपको लागि सेकेन्ड मोड भनेको थ्राइस अफ फन्डामेन्टल मोड हुन्छ सो 240 पनि आएछ त्यसो भए त अब यो दुईटा अप्सन मात्रै छ कि अरु पनि हुन्छ भनेर चेक गर्नु पर्यो थर्ड मोड चेक गर्यौं त्यो आयो 400 भनेपछि तीनटै 80 240 एन्ड 400 सबैमा रिजोनेट गर्न सक्ने रहेछ त्यसले अप्सन डी करेक्ट अप्सन देखिन्छ है आई थिंक बुझिदैछ नाउ हियर I think this is last question for this discussion. The length of a sonometer wire is doubled and its tension is increased 4 times. The fundamental frequency of the wire is changed in the ratio. Okay, so first of all we are going to write the equation for frequency of fundamental frequency for wire, and this is equal to 1 by twice L root under T by mu. So here two parameters are changed. Length is made doubled and tension is increased 4 times. So I am just going to write here 2 into twice L root under 4 into T by mu. Okay, so this will be equal to twice L and twice of T by mu, and these two cancel out. So it will be 1 by twice L root over T by mu. So the value of frequency remains same, which means that if we want to express these two value in the ratio, that will give us 1:1. So our option C is correct option. Okay, so यो फेरि एकचोटि बुझ्ने कुनै स्ट्रिङ सोनोमिटरको स्ट्रिङको लेन्थ डबल गरिएको छ एन्ड टेन्सन त्यसको 4 टाइम्स बनाएको छ भने फन्डामेन्टल फ्रिक्वेन्सीको रेशियो निकाल्नु छ सो फन्डामेन्टल फ्रिक्वेन्सीको फर्मुला हामीलाई थाहा छ f इक्वल टु 1 by twice L root over T by mu. दुईटा प्यारामिटर टेन्सन एन्ड लेन्थलाई मोडिफाई गर्नु छ ट्वाइस अफ लेन्थ मैले यहाँ युज गरेँ एन्ड 4 टाइम्स अफ टेन्सन. ओके, एन्ड अन सल्भिङ हामीले एक्ज्याक्टली एक्सप्रेसन पायो फन्डामेन्टल फ्रिक्वेन्सीकै जस्तै त्यसैले रेशियो निकाल्यो भने 1:1 हुन्छ. सो अप्सन सी करेक्ट अप्सन देखिन्छ. वेल, this much for this particular video. Okay, so keep watching, stay tuned, and please subscribe to get more and more MCQ and their solution and their explanation as well. So thank you for listening. Okay, thank you.